Let's talk about standard reduction potentials. The most commonly observed half reactions in aqueous solutions can be found in a table of standard reduction potentials. You should have one in your textbook, and you should find a whole bunch of them on the internet. One website that I like to go to that has all that information is do a search for the National Physical Laboratory in the UK. www.kaywae.npl.uk.npl.co.uk. CO is what they have. It's like their .com over there. Okay, company, corporate. Okay, and so if you go to that website, okay, that is where you find a lot of data. So you go to the table of contents. Okay, and this is where you find lots of information, not just for electrochemistry, but for other stuff. So hit chemistry right here, the link to chemistry. Electrochemistry right here. Standard electrochemistry, standard potentials. Okay, let me blow this up. Sorry. Under electrochemistry, look at standard potentials. You have a list of all the most commonly used half reactions. They're called electrode reactions, okay? For reasons that will become clear later. So these are all listed as reduction. Notice they're all listed as reduction. You have electrons on the left side. And what you have tabulated here, what are known as a standard reduction potential. So for example, the standard reduction potential for calcium ion is negative 2.84, and the unit here is in volts, okay? So that's a standard reduction potential. So what about H plus? This, by definition, this is given as value of 0. 2H plus 2 electrons gives you H2 gas. That's 0 volts. And fluorine has a standard reduction potential of 2.87, and lithium is negative 3.04. What do these standard reduction potentials mean? The number here, given in volts, tells you the likelihood of that reduction. Okay, the more positive that value is, the greater that tendency for that to occur. Okay, so if you compare half reactions, if you have two half reactions, okay, of these three, then which is the most likely to occur, has the greatest tendency to occur? Is it going to be A, B, or C? Okay, so we say that F2 is the most likely to get reduced, comparing the reactants, H plus, F2, and lithium plus, okay? H plus, F2, and lithium plus, we say F2 has the greatest tendency to get reduced, okay? Now, since reduction is another terminology I forgot to mention last time, since reduction, when something gets reduced, it causes something else to get oxidized, right? So if fluorine has a great tendency to be reduced, that means it has the greatest tendency to cause something else to get oxidized. So we say, so greatest tendency to be reduced, and we can relate that to the electronegativity. Fluorine likes to accept electrons, right? It's the most electronegative. Gaining of electrons is reduction. We can also say that is the best oxidizing agent. If something gets reduced, if you get reduced, you're causing something else to get oxidized. So something that's reduced, we say, is an oxidizing agent. Something that gets oxidized is a reducing agent. So if you do hear those terminologies, make sure you understand what it means. When you say oxidizing agent, that is something that is getting reduced. Okay, when you say reducing agent, you're talking about something that's getting oxidized. So we say since these are all written as reductions, okay, you're comparing the ones on the left, we say then that F among the reactants that are shown here, H plus, F2, and lithium plus, F2 has the greatest tendency to get reduced. Okay? So it's the best oxidizing agent among these three.